All right, now we come to the whole reason that the chain rule is called the chain rule. And it's because we can have multiple inside functions. We can have a function, an outside function with a function inside of it, and the function inside of it can have another inside function, okay? And we can keep going, just like Russian dolls. We can have as many inside functions as we want. And we can apply the chain rule multiple times to take the derivative of a composite function, or a composite of a composite of a composite function, all right? So basically, we're just applying the chain rule over and over. I'm just going to go straight to the example here because I think it makes more sense when you see it applied. So here we have y is equal to the square root of the natural log of x squared plus 1. So you can see we have the outside function here, y is equal to the square root of z. Okay? But z then is equal to the natural log function. So it's a natural log, and I'm going to say it's a natural log of u because then u is inside of the natural log function, and we can say u is equal to x squared minus 1. Okay, so we have a function within a function within a function. So let's try to figure out what dy dx is. So dy dx, okay, we're going to take the derivative of the first outside function. So we get 1/2 z to the minus 1/2, okay? And then we're going to multiply times the first inside function, right? So the derivative of natural log is 1 over u. And then we needed to multiply that times the next inside function. So the next side function is the x squared minus 1. So we just need to multiply by 2x, which is the derivative of x squared minus 1. Okay, so now we just need to put everything back together. and because now we have things in terms of z and u, and we want everything in terms of x. So so let's see. So first of all, I think I'll just cancel this 2 times 1/2, right? So that's going to give us, okay, z, so we got z is equal to the natural log of u, and u is equal to x squared. So we have the natural log of u, which is x squared minus 1, okay? That whole thing, we want to take that to the minus 1/2 power, okay? That's our that's the first function. And then we have times 1 over u, but u is x squared minus 1, okay? And then we have finally the 2x is still just 2x. All right? So you can leave it that way. That's just fine if you want to leave it that way. You could also write it as, oops, I wrote 2x. I meant to write x because I canceled that 2, didn't I? All right, let's get rid of that. All right, so I'm going to end up with x all over. I'm going to have x squared minus 1. And then I have the square root. It's in the denominator because it's negative. And then I have the natural log of x squared minus 1. Okay, that's what I get if I want to clean it up. But I would recommend, in fact, I actually prefer for you know, a lot of these problems that we're going to be doing, just to leave it in unsimplified form. Just leave it. Leave it, leave it, leave it. It's easier for me to check, and also saves you time, and it saves you the headache of making some little algebraic mistake in the process of simplifying. Okay, so do not simplify. Do not simplify your problems. I would recommend not simplifying it. In fact, I think I'll say on the quizzes and the exams, I'll say do not simplify. I don't want to see it simplified. It makes it easier on me. Okay. All right. Well, that's all of the examples I have, and I will meet you in class.